Okay, I'm recording. What I want to do first is take you over to my slide because there are a couple things I want to show you. Okay. Optional tutoring. We didn't go over this on Monday, but I want you to know it is optional. Optional is the first word. Its first name is optional. This is just because this is a synchronous class, and we did last week asynchronously. So if you need some help, I'll be here tomorrow morning from 8 to 9:20, and then Friday afternoon from 2 to 3:20. I fully expect almost nobody there. So if one-on-one is a good number for you, show up if you have some questions about 2.5, 2.6, and 2.7. I would like for you to have already seen the recording, so you're not just coming there saying, what did we do last week kind of thing. So that is completely optional. I'm not taking attendance. There's nothing new that will be gone over. Some of you are already done with 2.5, 2.6, and 2.7. You have no concerns at all. The other thing I want to talk to you about is this STEM internship at NASA for Hispanic students. It's funded by a Hispanic group. They have a scholarship that you can look at that's available there for the internship. But they're having a meeting today from 4 to 5. Let me open it up. I'm not going to drag you with me. I don't think you can see this. 4 to 5 Eastern. So 3 to 4 our time. 3 to 4 our time. There's a link there. You don't have to go to that meeting. It just explains stuff, and kind of having somebody explain stuff is kind of nice for you. But it is for STEM majors who are Hispanic. Okay. That's it. Let me drag your Heine back over here. There we go. And let's get going. We've got two things we're going to do today. We're going to finish up 3.2 with the graphs. We're going to cover A, B, C, D, E, and F on each one of those graphs. And then we're going to do dividing polynomials. So this is really sweet. We've got 7 graphs where we're going to do pretty much the same thing each time. And then we've got dividing polynomials, which is going to make you do a happy dance. I promise. You're going to say, this is the easiest thing I've ever done. You're really going to enjoy dividing polynomials, promise. Okay, we don't have a test till end of next week. So get working toward getting caught up. We'll have 6 sections for you to do by the time we finish today. All right, let's see. The first one I want to look at, this is still 3.2, finishing up the graphs. This is the first of the 7 graphs we're going to look at this morning. F of x equals 9 times x minus 2 times x plus 7 squared. Okay, we're only going to do A, B, and C on this one. So A asks us for n behaviors. So we're looking at n behaviors. Let's see. In order to determine n behaviors, remember from yesterday, we need to come up with the degree of this polynomial. So there's a 1 right there, or a 1 up here, but it's x to the first and then x squared. So that's an x to the third, and it's a positive number. There's no negative here. So x to the third, that's an odd degree. So I know it'll be a snake charmer. It's going to fall to the left, do something in here, and rise to the right. Those are the n behaviors that you're looking at. So you'll be using those little arrows, or you'll be saying, I think primarily on my math lab, you're saying falls to the left and rises to the right. They're going to have all 4 combinations for you there in the multiple choice, so you've got to be careful that you're looking at the right one. I've made that mistake a few times. Okay, real zeros, x-intercepts, what else do they call that? Solutions. Those are interchangeable terms. Real zeros, x-intercepts, solutions. This is so easy. We have not done one like B yet. This is so simple, though. So the real zeros, there we go. The real zeros, there's no variable there, so ignore the 9. The x minus 2, you know that when it's contained within an x, it's a liar. So x is going to be a positive 2. You know that when it's contained within an x, it's a liar. So x is going to be a negative 7. Those are the two real zeros or x-intercepts or solutions. What that means for us is that our graph is going to go through 2 and going to go through negative 7. We'll graph in a minute, but I want to just talk to you about what this is without us needing it quite yet. So our graph will go through, there's our graph, let's say. We know it's going to fall to the left. We know it's going to rise to the right. It's going to do something in here. It's going to cross at 2, or 2 is one of our answers. Negative 7 is one of our answers. Now what we learn in C, the multiplicity of each, the multiplicity of that one, that exponent that's up there is a 1. That tells us that at 2, our function is going to cross the x-axis at 2. The multiplicity of the negative 7 is a 2. When you've got an even multiplicity, you're going to have a turnaround. I'm going to just abbreviate that turnaround, TA. So what that tells us is that at 2, well, let's see, we're going to start here at negative 7. At negative 7, this is going to be a turnaround place. So remember, it's falling to the left, so it's coming from down there. It's going to come up here. It's going to have to turn around at negative 7 because the exponent is an even number. So we're going to come up here, and it's going to turn around. And then what I also know is that the next time it's going to cross the x-axis, it's going to cross it at 2. And we know it's going to do this. It's going to cross it and go screaming through it because the multiplicity for that 2 is a 1, is an odd number. So we're going to do this 7 times. You're going to get used to this. But when it's got an odd multiplicity, when the x is only once there, or 3 times, or 5 times, it's going to cross through. It's just going to go screaming through the 2. When it's got an even multiplicity, the negative 7 had an even multiplicity, it's going to turn around there. Now, I don't know where it crossed the y-axis. You can see that the y-intercept is the next thing we worry about, but we're not worried about it on this one. This one didn't ask you for that. This problem, the first 2 will only ask us for the first 3, but I want to dovetail with what we're going to learn later. So these 3 pieces of information we're doing on number 1. Let's go to number 2. The next one we are looking at is f of x equals x to the third minus, did you say odd equals cross and even equals turn around? That's exactly what I said. Yes, that is exactly, because this had an odd multiplicity of 1, so it's a cross. It's going to cross straight through and go screaming through there. Now that doesn't mean that 2 is an odd number. That's not what we're saying, and I know you got that. 2 is not an odd number, of course, but its multiplicity is. And it's the multiplicity that tells you if it's going to cross or turn around. Okay, let's look at x to the third. Yes, the exponent, Chloe, exactly. Minus 42x squared plus 441x. Okay, here we got to read straight off what the x's were. Here we're not going to. We're going to have to factor, but we'll get to that. Number 1 asks you for n behaviors, or A asks you for n behaviors. So let's look at our highest exponent. That's x to the third. You know that an x to the third with a positive in front of it is going to fall to the left and rise to the right. That's what all odd exponents will do. The degree of the equation, the highest exponent you can find, that's x to the third. So we know it's going to look like a snake charmer. So fall to the left, rise to the right. Fall left, rise right. Okay, the second thing we have to worry about are the real zeros, the x-intercepts, the solutions. So let's factor this. So let's take an x out of each piece. Got this x, that's going to be handy in a minute. Let's factor this, x and x. The signs need to be the same, and they'll need to be negative. And then we're looking for two numbers that multiply to give us 441 and add together to give us 42. When you have really weird stuff like that, often 441 is going to be a perfect square. Let me get that out of the glare a little bit. Maybe there. So I'm going to look and see if 441 is a perfect square. Second, x squared, 441 equals, good, 21, and 21 plus 21 will give us 42. So this is one of those perfect square ones, 21 and 21. So let me clean this up to help us when we try to decide multiplicity. I'm going to keep the x, and I'm going to write the x minus 21 fancy pants like that. So real zeros with the x-intercepts or solutions, all of that, x is going to equal 0. Whenever you've got a standalone, that's a 0. And then we've also got 21, because remember, this is always going to be a liar when it sits inside an x phrasing. So that we've got the real zeros are at 0 and 21. So if we were graphing this, there's 0, way out there's 21. Now let's look at C, where we talk about the multiplicity of each. Because our 0 has an exponent of 1, that exponent being odd tells me it's going to cross. So it will cross at 0. And then the 21 has an even exponent. That tells me it's going to turn around at 21. Okay, so we're going to skip the middle stuff. We'll get there on all the other graphs. Let me just sketch it so you can see what's going to happen. We know it falls to the left. We know it rises to the right. It'll do something else in there. We know it's going to cross at 0. So it's going to come through here and cross at 0. And then it's going to have to turn around at 21. So it's going to come back down and bounce off of 21. And that's what that'll look like. We don't know how high this is going to go. We could find out. We could plug in a 1 and see how high it goes. We could plug in a 10 and see if it goes way up or if it just barely skirts here. That's not going to be something we have to worry about a whole lot. We're more concerned with where does it, what are its end behaviors, and is it crossing or turning around at each 0, at each real 0, at each x-intercept, at each solution. Interchangeable words. Okay, the next 5 that we do, we'll run through this entire list. So let's look at our third graph. F of x equals x to the third minus 6x squared minus x plus 6. Okay, end behaviors, that's our first thing. Let me drop this down a little bit. End behaviors is our first little guy. And again, we've got an x cubed and he's positive. So I know he'll be falling to the left and rising to the right. So falling to the left and rise to the right, just like a snake charmer does. Our real zeros, we're going to have to factor this. It's got 4 terms, so I know that's going to be factor by grouping. I'm going to look at those 2, then I'm going to look at those 2. Let's play that game one more time. X cubed and 6x squared have x squared in common. When I factor out an x squared, I'm going to get x minus 6. Minus sign is our next thing, so we drop a minus down here. And a lot of you are uncomfortable pulling out a negative, so don't worry about it. Cheat. Take this and put it over here, and then figure it out. What must we be multiplying negative? Well, what must we be multiplying x times to make it be a negative x? We need a number here. So we're going to put a 1 there. Negative 1 times x will give us negative x. Negative 1 times negative 6 will give us positive 6. I know we've worked with minus signs before, but I don't think we've ever put a 1 there. So when it doesn't have a number, because of our next step, you're going to need to put a 1. Okay, now we're looking at what that has in common with that. And you can see that they both have an x minus 6. Let's gather the garbage. X squared minus 1. Ooh, that's still got square on him, so we can still factor him. That is the difference of two squares, so x plus 1, x minus 1. There, remember on B, we're looking for real zeros, x-intercepts, solutions, so now we can read them off. X equals the opposite of that, because, you know, I mean, if we had x minus 6 equals 0, we'd move it over, and that's how we're getting a positive 6. That's how that's a liar. When we move it across the equal sign, he turns to his opposite. Same thing going on here. We've got a negative 1. Same thing going on there. We've got a positive 1. I put that positive. That's not necessary. All right, let's see what's next. We need the multiplicity of each. So in C, we're looking for each of these multiplicities. The multiplicity will tell us its behavior. So I'm seeing that this x has an exponent of 1. That means it will cross at 6. X plus 1, well, which is a negative 1 on the number line. That's also got a multiplicity of 1, so it's going to cross there also. And then this one has a multiplicity of 1, so it's going to cross there also. Okay, let's move on and do these others that we haven't attacked yet. They're not difficult. Nothing here is difficult. It's just a lot of steps. And I went and played with it in my math lab a little bit. It's not a ton of fun, but get through it. It's not long. Okay, we're looking. Well, let's look at the graph and see what we've got going so far. We know that it is going to fall to the left. We know it's going to rise to the right. What do we have here? We have a 6. We have a negative 1, and we have a positive 1. And it is going to need to, okay, we don't have enough information yet. Well, we do have enough information yet, but what we're looking at is, let's go ahead and get the y-intercept out of the way. The y-intercept, just like we did the other day, just like we did Monday, whenever you see that word intercept, that tells you to put a 0 for the other variable. So we're going to put a 0 for the x, because it says y, so we're going to put a 0 for the x. And then just plug it in. You can plug it in here, or you can plug it in here. It doesn't matter. It's going to be a lot easier to do up here. X to the third power, that's 0 to the third power, that cancels that out. Minus 6x to the squared, that cancels that out because negative 6 times 0. Minus 0, so right there, always, sits the easiest way to get the y-intercept. You could plug it into here. You could plug in 0 minus 6 gives you a negative 6. 0 plus 1 gives you a 1. 0 minus 1 gives you a negative 1. Negative 6 times 1 is negative 6. Negative 6 times negative 1 is a positive 6. But it's a whole lot easier up here because that all cancel. Okay, so we know that we're going to have to go through 0, 6 also. That's a new piece of information we didn't have on 1 and 2. They didn't ask you for that. Let's look before we go playing with this. Let's see what we're going to have to do here. Yeah, it's going to be gorgeous. They want to know, is it an even function? Therefore, it would have y-axis symmetry. It'd be the same thing on the left as on the right. Is it an odd function, where you would take it from the origin and spin it 180 degrees and turn this around this way for origin symmetry, or just anything else? Well, let's do it the easy way. Let's look at the exponents. If they're all even, then it's got y-axis symmetry. If they're all odd, if all the exponents are odd, it's got origin symmetry. If we've got a hodgepodge, it's neither. So there's an odd number, so maybe this has origin symmetry. Oh, no, that let us down. So this is a neither, just like we were doing forever ago. And now let's graph it. So we know we're coming from here. We got to cross through negative 1. We know that's a crossing place. To get to 1, we're going to have to go up here, hit the y-intercept. That's an extra piece of information on this graph that we didn't have. Come through here. Let's see what's going to happen at 1. We're going to cross through. So scream on through there. And then we're going to have to cross at 6. So we're going to have to come back up and looky there. There we go, out the picture. So we come in down here. And this is not the definite. I mean, I know I go here, I know I go there, I know I go there. I don't know how low I go here. It could go way down here for all we know. We're not going to figure that out. We're not concerned too much with all those details. Okay, ready to go? Let's go to a fourth one. Anybody need me to hang on for a second? Or you have a question?
Hold on for a second.
Great. I will do that, Kaylina.
Okay, I'm good.
Okay, thank you. Thank you for feeling comfortable enough to say, hold on. All right, let's do the last 4 graphs here. To get the multiplicity, you always want to look at the factored version, right? Yes, absolutely. Yes, you have to look at the factored version to get the multiplicity. Yes. Yeah, you can't tell until you break it down and look at the zeros. And that is absolutely why it's in this order. I had to work on my own order. I don't like some of the orders that I see. Okay, let's look at number 4, and you are welcome. F of x equals x to the 4th plus 12x to the 3rd plus 36x squared. It's a 3 right there, as you would expect. X to the 4th plus 12x cubed plus 36x squared. Okay, we're out of the snake in the grass one. This is our first one that's not a cube. Let's start with A. And behaviors. Look at the highest exponent. It's a 4. And so that's an even exponent. So you know that that's like the parabola. It's going to rise to the left, do something in there, and rise to the right. It's going to look like a parabola on the ends. It's going to, because it's bigger than a parabola, it's going to do some funky things in here, but that's okay. We know the ends are going to rise on both sides. Okay, next thing we want are the real zeros, the x-intercepts, the solutions, that kind of thing. We want to factor this thing. So let's see, I see that they all have an x squared, so I'm going to pull out an x squared. And then I'm going to be able to factor this. X's, signs need to be the same, and they'll need to be positive. We're looking for 2 numbers that multiply to give us 36, that add together to give us 12. You can see what they're doing here. They're liking that multiplicity of 2 because that's a bounce around, that's a turnaround. So they're providing you with this is our second one to do that. Okay, let's clean this up so that it'll help us with multiplicity. I'm going to call it x squared, and then I'm going to call it x plus 6 squared. Get fancy pants and put those 2 together. Okay, we're still working on real zeros. So the x is here. Take the square root of x squared, you get a 0. And here you get a negative 6. So our real zeros, this is still our B answer, our real zeros are solving it. This is the solving part of it, are 0 and negative 6. Now let's look at that new thing that you've got going, the multiplicity. That's really the only thing here that's new. Everything else is gathered up from Monday or last week. And multiplicity is very simple. If the exponent is even, then we know the multiplicity is going to tell us that it's going to turn around. So this 0 has a multiplicity of 2. It's going to turn around there at 0. It's going to bounce off of 0. Negative 6 is doing the same thing. It's going to be a turnaround there also at negative 6. Okay, let's start graphing this. Let me move this over here. I don't know where to move it. There we go. Okay, so we know that this is going to rise to the right, rise to the left, rise to the left, rise to the right. We know we've got 0 as a bounce. We know we've got negative 6 as a bounce. as a turnaround place. Let's find the y-intercept. Well, look, we've found the y-intercept, haven't we? Right there. It's only going to cross the y-axis once, and we've already found it with a 0. But let's play the game anyway. So when you're looking for the y-intercept, D, remember, whenever you're looking for the y-intercept, when you find the word intercept, that tells you to zero out the other variable. So we're going to put a 0 in. It's easy to do here, but it's way easier to do up here. 0 to the 4th, 0 to the 3rd, 0 squared. All that will zero out, and we'll get 0, 0 as our y-intercept. We already found it as a solution, as a real 0. Okay, next let's look at this even, at the symmetry, at the possibilities for symmetry. Remember that it will have y-axis symmetry if all of the exponents are even. It'll have origin symmetry if all the exponents are odd. Okay, there's an even number. Cool. Maybe this will have y-axis symmetry like you have y-axis symmetry. Nope, there's an odd. So this is a neither. Most of these will be neithers. We will come across one that's not today, and then you'll have others later on. And now let's graph this guy. Okay, so we know this is a turnaround, and oftentimes I'll even write myself a note there, TA, turn around, turn around. So it's going to come in here, it can't cross, it's got to bounce. And now I've got to bounce off of this one also, so I got to come back down to get to him. So I'm going to come back down to get to him, I'm going to bounce, and then head on out of here. Don't know what's happening in there. It could go way up high. The way to figure that out, if we cared, and we don't in this one, but we will in one in the future. So let me show you what we would do. We want to know what happens in here, so let's figure out what happens in there. We know what happens at 0. It's a 0. We know what happens at -6 on the x-axis. Let's grab something in between. Let's grab a -3. So then we would be doing -3 to the 4th power. That's an 81. Then we would be doing -3 cubed. That's -27 times 12. Gonna need help on that one. -27 times 12 gives us -324. And then -3 squared is 9. And 9 times 36 is +324. Well, what do you know? So we get an 81 out of that. So at -3, this little humpy, I've drawn him way too low. He's going to go way up high and come back down. But you're not going to have to worry about that. They're not going to have one that has something like that and something like that for you to figure out. They're going to, your work is to figure out end behaviors and the bouncing and the crossing. That's what your work is, and where the zeros are. Nothing more than that, except for one problem, which I think it becomes obvious why we have to do it there. So you're matching on these. Okay, let's move to another one. Let's look at number 5. F of x equals 20x to the 3rd minus 100x minus x to the 5th. Let me make sure I changed this one because I didn't like, yeah, that's good. Because the one they gave me for a practice one, for a view and example, didn't have the difficulty level that the actual problem does. So I went and changed it. Let's see, is that x cubed? 20x to the 3rd power. Yeah, that little thing sitting there doesn't look like a 3 very much. Yeah, it is. Okay, let me grab attendance real quick while I'm thinking on it. Okay. Yes. Okay, let's see. This is in the wrong order. We've got to have our first guy, our big guy first. So let's rewrite him. F of x equals, he's got a negative on him. Then the next lowest one is this 20x to the 3rd. That's a plus 20x to the 3rd. And then this guy. Okay, I'm going to cross him out so I don't get confused there. Okay, when you've got a negative on your big guy, you're going to need to factor out that negative. But first, that's later. First, let's do end behaviors. Okay, so end behaviors. Oh, this one's interesting. This is an odd one, so remember on odd ones, there's like the snake in the grass. Only problem is this has a negative on him, so it's going to go in the other order. Flip this guy, do his mirror image. So it's going to rise to the left, do something in there, and then lower to the right. It's going to be the inverse of that, the mirror image of that. Rising to the left, lowering to the right, because it has a negative in front of an odd. This is the x to the third. So x to the fifth is similar. It'll be a little bouncier, a little crazier in here. So that is rising to the left and falling to the right is what you'll be matching to. Okay, now we're looking at real zeros, x-intercepts, solutions. So we're going to be factoring this. So when you've got a negative on your big guy, you want to factor that negative out. And then I can see they've all got an x to give. So let's go in and factor out a negative and an x. So we're left with x to the fourth minus 20x squared plus 100. Okay, look what we've got. We're just practicing all kinds of factoring. Let's do that mu thing here. I'm going to keep this negative x squared, or negative x. I don't want to forget him. But what I want to do is I want to let mu equal x squared. You were hoping that would go away. And it pretty much will at this point. I don't think we do this again in this semester. So let's factor it. 100 plus, oh, there's an x squared. Let mu be there. Then a 20, then a minus sign, and then, you know, guaranteed that's going to be mu squared. I don't want to forget that negative x. I'm so afraid I'm going to forget him, and he matters. Let's keep factoring this. Signs need to be the same, and they'll need to be negative. I'm looking for two numbers that multiply to give me 100 and add together to give me 20. I gave it away. So 10 times 10 will give you 100, and 10 plus 10 will give you 20. So we got 10s in there. And you know, you're kind of getting used to that idea. X plus 6 on the previous problem. We had an x plus something else, x plus 21, I think. They do that to you. Okay, but be careful here. Be real careful. We're not done yet. This is mu. This is not x. So we have to keep going. So what we're going to want to do here is we don't have an equal 0 happening, but we are going to go back and resubstitute right now. So x squared minus 10, x squared minus 10, or we can consider this x squared minus 10 squared. I don't want to forget this negative x. Okay. Problem with this guy is this is not x. So what we're going to have to do is we're going to have to think of it as being x squared equals 10. And then we're going to be taking the square root of both sides, as you've been doing before. This is nothing new. X equals, you put the radical on positive or negative square root of 10. Okay, let's gather up what we've got here. So let's see, B asked you for the real zeros. So this real zero, this negative x, is just going to be a 0. Negative times 0 still gives you 0. So that negative x that we've been dragging down here, dragging down all the way, that's just a 0. This thing, though, is a little bit trickier. We have a plus square root of 10 and a minus square root of 10 happening there. Okay, those are the zeros. Let's look at the multiplicity of each one. The multiplicity of this one's super easy. There's just one of them there. So it's going to cross there at the 0. Now this is more than that. This has got a 2. This happened twice. The plus and minus buried in here happened twice. So we're going to turn around at square root of 10, positive square root of 10. And we're going to turn around at negative square root of 10 also, because the multiplicity that's happening in there is a 2 for whatever we did in here. We ended up with a plus square root of 10, and the multiplicity is 2. We ended up with a minus square root of 10, and the multiplicity is 2. Okay, let's look at the y-intercept. You know that anytime you see the word intercept, you're zeroing out the other guy. Where do we go? Way up here. Let's put in zeros. 0 to the 5th, 0 to the 3rd, 0, 0. Okay, so we're at 0, which is this crossing place too. So this did not give us any more information. Let's look and see if this has y-axis symmetry, origin symmetry, or neither. Let's see the exponents. That's an odd number, so maybe it has origin symmetry. Odd number, an odd number. So this is our one that is not the neither. This is an odd function, and so it will have origin symmetry. We'll look at that in a second. Now let's go graph it. So we know we're let's see, what's our end behavior? Coming screaming in from the left, upper left. We're going to go running out that way. We've got a 0 where we're going to cross because it's just got odd multiplicity. Square root of 10. That's square root of 9 is really close. So that's going to be a positive 3 and a little bit. Let's look in your calculators just to get a better idea, a clearer idea. Square root of 10 equals 3.16. So 3.2. So, you know, if you've got 3 sitting there, you're going to be right here. Maybe, you know, some idea like that. And then if we've got also, there it is, negative 3 and a little bit. So we're going to be on either side of the 3's. Okay, so we want to turn around here, and if you want to write a little note to yourself, turn around there and turn around there and cross there, CR there, or whatever. So you don't want to forget what you're doing. Okay, so it's got to come in from here, and it's going to bounce. It's going to turn around just past negative 3. It's going to have to cross here. So I'm going to have to bring it up somewhere and make it cross. And then it's going to, as it crosses, there we go, it's crossing here. It's got to come back up here, and it's got to turn around. And there it goes, and it can scream on out of there. It probably wouldn't come back in and hug that, it, you know, go out evenly like that. And looky there, we've got origin symmetry. If we take this valley and then on out and turn it 180 degrees, it'll be this little hill and going out. So if you were able to cut this out and spin it 180 degrees, this point would be there. Exiting out lower right would end up being coming in upper left. So there's the origin symmetry. Y-intercept was 0, 0. That was extra information. We already had it crossing at 0. Okay, so kind of cool. Let's look at our last two. Kelina, you good?
Yes, I'm good.
Okay. You don't sound so good. You sound kind of down today. Hope all is well. Or maybe you're just concentrating so hard on the math.
I'm just really tired. I was out all day yesterday with my mom for her birthday.
You were out all day yesterday doing what?
Doing stuff with my mom for her birthday.
Oh, your mom's birthday. That's the part I missed, I think. Well, congratulations to her. I guess everybody gets one every year, but still it's fun. Fun to have a birthday. Okay, let's see. Number 6, f of x equals 4x squared plus x to the third. Okay, let's see. This is in the wrong order. Let's get it in the right order. Big guy goes first, x to the third plus 4x squared. I'm going to cross that out so I don't get confused. I need n behaviors. That's first. N behaviors, this is just x to the third. This is a snake in the grass, so it's going to lower to the left, do something, and rise to the right. Falls is what they call it. Falls to the left, rise to the right. Okay, let's look at the real zeros. We need to factor this. So they both have an x squared. I'm going to pull that out, and I'm left with x plus 4 on the inside. So this real zero is a 0. This one, remember when they're pocketed in there, they're liars. So that's a negative 4. So our real zeros, x equals 0 and negative 4. That's where we're going to be crossing. That's the x-intercepts. That's where we're going to be crossing the x-axis at 0 and at -4. Next thing they want off of you is multiplicity of each one. Are they crossing or are they turning around? The 0 has an exponent of 2, so that tells me he's going to be a turnarounder. That guy's going to turn around at 0. The -4 has an exponent of 1, has a multiplicity of 1, so we're going to be crossing there at the -4. Let's look for the y-intercept. Let's see. Anytime you have the word intercept, you know you're zeroing out the other variable. When I put a 0 in there and a 0 in there, I get a 0, but I already knew that. I already knew I was going to cross the x-axis at 0. So it's going to create a little bit of a problem here. We'll see it in a minute. Do we have y-axis symmetry if all the exponents are even? Do we have origin symmetry if all the exponents are odd? Nah, there's a mixture. So we have neither going on here. This is not going to be a lovely graph. It's just going to be a hodgepodge graph. Let's go ahead and graph it. Let's see. We know we're coming in down this way and going out that way. We know that we are turning around at 0 and we are crossing at -4. So we're going to come in here. Let's see, what are we doing here? We're crossing. So I'm going to go through. And then I know I want to turn around, so let me come back down to 0 and turn around, and there we go, right on out. Looks like a snake in the grass. Okay, my memory is that I've written the phrase extra points on this one, because my math lab is not going to let you get away with this. I think that what they've got for you is a little hill, and then they've got another one that's a bigger hill, a mountain. So you're going to have to go in and investigate, like I showed you on the one problem where we built a t-table. Because on this one, this is the next to last graph you're going to do, they are going to ask you to be pickier about what happens in here. Does it just barely go above? Does it climb way ahead? What does it do there? So let's set ourselves up a little t-table. We know what happens at -4. I mean, that is literally -4, 0. That's that point. We know what happens at 0. That's 0, 0. Let's find something that happens between there. So let me just grab -2. And we're just going to plug in -2 into our equation. So -2 times -2 times -2 gives us a -8. -2 times -2 is 4. 4 times 4 is 16. So we're getting an 8 there. Okay, that might be enough information for you to gauge that this is going to have to go way up to 8, right there in the middle. Yeah, it's because it's going to be smooth and continuous. So that ought to be enough information. So you would not pick the one that had the little hill, you would pick the one that goes all the way up to 8. And so of course this isn't going to be a corner. This is going to be nice and smooth. These that I've drawn here are just, ideas, general ideas. So you will have to come up with what's happening between those two places with a t-table. Just plug it in. Let's look at our last one and then we'll go do our happy dance with division. Number 7. F of x equals x squared times x minus 2 to the 3rd power times x plus 5. There, that's a pretty 3. I did that one so everybody can read that. Good deal. This is going to be easier because they've done the factoring for us. This won't take long. This has got a funny little thing. It's the first time the multiplicity has been 3, so I'm glad to, I made sure I had the opportunity to show you one of those. Let's look at end behaviors first. These are multiplied together. Remember up here, we just grabbed the 3 from the big guy. We played with this concept on Monday, but the concept is that when they are added together, you just grab the big one. But when they're multiplied together, you've got to add them all together. So to find the degree, we're going to have to go 2 plus 3 plus 1. So we've got 2 plus 3 is 5, plus 1 is 6. So that's just like a parabola. That's an even multiplicity, or an even degree, an even degree. So it's going to be rising to the left, doing some funky stuff in there, and then rising to the right. Just like a parabola does, because it's got an even degree, 2 plus 3 plus 1, because they're all multiplied together. Okay, real zeros are going to be very simple here. We've got a 0 there, x equals 0, x equals 2, and x equals -5. Those are liars. And 0 can't be a liar because there is no negative and positive 0. Let's look at the multiplicity of each. 0 has 2, so you know that this is a turnaround place. 0 will be a place where we'll turn around. 2 has a multiplicity of 3, so you know it's going to cross. There's no doubt about it, it's going to cross. That's important. But it's also going to do a squiggle, and that matters because it's bigger than 1 or 2. When you've got 3 or 4 or 5, it's going to do a squiggle at that crossing. And I'll show you what that looks like in just a second, and I'll slow down for that part because this is the only time we're talking about squiggles. But squiggles happen when the degree of that 0, when the multiplicity of that 0 is a 3 or bigger. When it's a 1, like this one, it's just going to cross through. When it's a 2, it's going to turn around. But anything bigger than that, okay, how you determine if it's going to cross or turn around, if the multiplicity of it is odd, then it's going to cross through. If the exponent is odd, it's going to cross through. So on this -5, that number right there, that exponent is a 1, so it's going to cross through. This guy, the 0, that's 2, it's even, so it's going to be turning around there. 3 is odd, so it's going to be crossing, but it's bigger than 2, so it's going to be doing a squiggle thing. And that's real easy to figure out and real easy to see. So let me show you. Who was that? Felicia, did you get that about the odd and even crossing and turning around? Good deal. You're welcome. Okay, let's keep going on these others. We've got zeros. That's very likely that we've got the y-intercept, but not necessarily, especially when they're multiplied together. So looking for the y-intercept, let's start with a 0. 0 squared, well, that does it right there. Because whatever these are, they're getting multiplied times 0. This, I mean, let's play the game. If we put a 0 in here, -2 to the 3rd power will give you a -8. 0 plus 5 will give you 5 to the 1st. So -8 times 5 is -40, but clunk times 0. So 0, 0 is our y-intercept. What does this have? Does it have y-axis symmetry? Are all these exponents even? No. Are all these exponents odd? No. So it's just a dud. It's just wandering around. Okay, let's graph it now. Got some new things to look at here. Let's see, we're going to go through 0, we're going to go through 2, and we're going to go through -5. We know it's going to start up there, we know it's going to end right there. Okay, it's going to cross at -5, so I want to come screaming through there. I'm going to come down here. Next I've got 0. 0 is a turnaround spot, so I'll come back up to 0, but I got to turn around, I can't cross, because 0 has an even multiplicity. When you have even multiplicity, you're a turnaround. And then the next thing we've got to do is we're going to have to cross at 2. See, we're down here, we got to get up there. So we're definitely going to cross at 2. But because we have this huge exponent, anything bigger than 2, we're going to squiggle there, squiggle, 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 and then we'll head out. So when you've got an exponent of 3 or bigger, you're going to squiggle, whether you're odd or even. If you were even, coming across there, if you were even, you know you have to turn around, but still you'd go squiggly, 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 and then turn around, something like that. If you were x to the 4th, if you had a 4th multiplicity. So first, whenever it's a 1, like the -5 is, you're going to cross through, go screaming through. When it's a 2, That's an even multiplicity. You're going to turn around as we did. We didn't go above, we just turned around. Anything bigger than that, the rules are still the same. The rules are still the same, that the odd ones will cross, the even ones will turn around. But if you've got a great big number, it's going to take its time doing that. It's going to squiggly, squiggly, squiggly cross. Or squiggly, squiggly, squiggly turn around if it was a multiplicity of 4. Okay, that is it for 3.2. Anything bigger than 2? Yes, anything bigger than 2. If it's 1, it's going to be crossing. If the exponent is 2 or the multiplicity is 2, these are multiplicities, so this is dealing with C. If the multiplicity is 2, it's going to turn around. If the multiplicity is 3, it's still going to cross, but it's going to squiggle. If the multiplicity is 4, it's still going to turn around, but it's going to squiggle. If the multiplicity is 5, it's still odd, so it's going to cross, but it's going to squiggle, etc. So they'll still maintain their odd, even crossing or turn around, but anything bigger than 3 is going to involve a squiggle. And we only looked at this one that has a squiggle. It does sound good. It's sort of fun to say. Okay, that's fun to say. Let's do the stuff that's fun to do. Let's look at dividing polynomials. Now, here's me loving you or not loving you. There are 2 ways to do this, to divide polynomials. There's the old-fashioned long division way, and then there's the way I'm going to show you today that is just going to make you do a happy dance. I am not going to make you do the hard one on the test. I want you to follow it because I want you to fully appreciate the synthetic division that we're going to do. So this section is called dividing polynomials. Let's first, okay, let me build you one. We got an x plus 7 going into x squared plus 13x plus 44. This is called the divisor, and oh my gosh, there's a killer problem where you're going to need to know each of these pieces. That's the divisor. This is the dividend, and what we get up here is the quotient. The answer in a division problem is the quotient. So what goes in is the divisor. What you're going into is the dividend, and the answer is the quotient. You're not going to have to know this for the test. This is not a vocab class.
What's the title of the section say?
Say it again.
What does the title of the section say?
Dividing polynomials.
Thank you.
Okay, and one other thing that, well, I'll wait on that. I'll wait on that for one other thing. Okay, how to divide this out. Remember, this is not what you're going to have to do, but just do sit and fully wallow in this, fully appreciate this, so that you can really love the synthetic division. The way you do this is you take the first guy here into the first guy there. You say to yourself, what do I have to multiply x times to make him be x squared? Just like if you had 23 going into 575, you'd say, how many times does 2 go into 5 in long division? That kind of thing. So what do I have to multiply x times to make him be an x squared? That's an x. Doesn't matter where you put it up there. Now I've got to multiply both of these times x. So x times x is x squared, and I'm going to line them up in the x squared column. Then x times a positive 7 is plus 7x. Now, if we were to do this, we do 2 times 2, well, 2 times 23 is 46. And then what would we do? Of course you would. You'd subtract it. So that's what we're going to do here. We're going to subtract that one and subtract that one. That will cancel this out. That has to happen when you're dividing polynomials. It doesn't happen here, but it has to happen here. 13x minus 7x is 6x. Bring down the next term, which is what you do. And then we start all over again. What do you multiply x times to make him be a 6x? That would be a 6. So I'm going to throw a plus 6 up there. And then I'm going to multiply these. 6 times x, 6 times 7. Then I'm going to change the signs. I'm going to subtract. Those are gone. I've got 2 left here. That's my remainder. And up here I would put plus 2 over x plus 7. You're not going to have to do that. Even when they ask you to do it, you're just going to use synthetic division. So the first couple of problems are going to say use long division. Well, what are they going to do? Crawl through your computer and see that you didn't use long division? You're not going to use this method. This method is a pain in the rump, and I'm just showing you so that you know what you're doing so that you know, so you can fully appreciate how wonderful synthetic division is. I'm going to leave a space over here because we're going to come back here and do synthetic division in a minute on this problem so you can see how easy it is. Before we move off, if we wanted to, like, okay, 5 goes into 10 2 times. You know that you could multiply those two together to get 10. Same thing here. If we FOIL x plus 6 times x plus 7, if we FOIL that, we'll get x squared plus 13x plus 42, and then add in our remainder. That'll make that a 44, and we end up with what we started with. So if you multiply the quotient times the divisor, you'll get the dividend. Don't forget to add in the remainder. So that's another question that you've got, is if you multiply the quotient times the divisor and add in the remainder, you'll get the dividend. So just, just play along with my math lab. I thought about taking it out, but I thought, no, I'll leave it in. Let's do 2 more long division problems. Let's look at x minus 1 going into x to the 3rd plus 3x squared minus 8x plus 4. Same game. What do I have to multiply x times to make him be an x to the 3rd? And that's an x squared. So let me multiply x squared times each of these and line them up. X squared times x is x to the 3rd. X squared times a negative 1 is negative x squared. I need to change the signs. Make that a plus. Those cancel. They have to when we play this game. 3x squared plus 1 more x squared gives us 4x squared. Bring down the next term. Do the same thing. What do I have to multiply x times to make him be 4x squared? That would be a 4x. Now let me take 4x and multiply him. 4x times x. 4x times negative 1. Change the signs. That cancels. Negative 4x plus 4. Same game. What do I have to multiply x times to make him be negative 4x? Negative 4 times x. Negative 4 times negative 1. Change the signs. Those have to cancel. Those happen to cancel. Yay, we get a 0 here. That means that x minus 1 is a 0 of this guy. That means it works. When we divide x minus 1 into this, we get something without a remainder, and that's going to matter a lot to us coming up. So when it doesn't have a remainder, those are our heroes. Those are our winners. Okay, so that would be the answer there. I have one more that I just want to set up with you because I don't want to kill you with long division. You're not going to have to do it. Let's put x minus 3 out there. Let me start over. They're going to give you something like 5x to the 4th minus 2x squared plus 3x divided by x minus 3. And you're going to have to translate it. So you put the x minus 3 there, 5x to the 4th. I don't have a third. I'm going to have to put in a 0x to the 3rd if you were doing long division. And when you do synthetic division also, that matters. Then an x squared, so minus 2x squared, then an x, and we don't have a number, so we're going to have to tack on a plus 0. So wherever you start, this one started with x to the 4th, you've got to have x to the 3rd, x squared, x to the 1st, and x to the 0. You've got to have all of them down to a constant. And then we would do that routine, and I'm not going to show you that routine. I'm good with skipping that for now because you don't have to do these. Okay, let's go through and do these 2 problems with synthetic division. What we're going to do with synthetic division...
Can you go back to what you were just doing? Can I see?
Yes.
Thank you, Sue.
You're good, Kaylina?
Yes.
Okay. Okay. Let's go. I'll do those in a minute. Let me introduce you to synthetic division first. Let's say that if you have 3x to the third power plus 2x squared minus 3x plus 3 divided by x minus 2. Let's start with that problem. I want to go back up and show you how easy the other ones are compared to long division. But first, I want to get you to see what synthetic division is. So it's synthetic, synthetic division. Okay, what we're going to do is we're going to look at this guy. You know he's a liar, so take the truth. X minus 2, that gives you a 2. Build him a little box over here. We're going to isolate him off. So we're going to always take the opposite of this one. We're going to take what the x minus 2, if it were x minus 2 equals 0, move it over. So this is a liar. We're always going to take the opposite of that. Take the 2. And then just take the coefficients. 3, 2, negative 3, and 3. And make sure we've gone x to the third, 2, 1, 0. We've got all the parts we need. Okay, draw yourself a little line there. Bring down the first number. Then every time you've got a number here, you're going to multiply times that number. 3 times 2 is 6. Put the 6 there in the next column. Add these. So we're going to be multiplying to get to here. We're going to add here. So 2 plus 6 is 8.
Where did you get the extra 3 at the end?
I don't have an extra 3. It's right there. So it's 3, 2, negative 3, 3. 3, 2, negative 3, 3. I have 4 numbers, and I just put 4 numbers there.
That's 5 numbers.
Well, this 2 comes from here.
Oh, okay. I didn't see the box.
Yeah, that's his little box to keep him separate from those guys. So you're sure you're good?
Yes, I just didn't see the box around the 2. I thought it was a 21.
Oh, okay, okay. Yeah, so we will separate this little guy that we're dividing by. We'll separate him in his own little box, and then we'll put the coefficients here. So 3, 2, negative 3, and 3 go there. Okay, so bring down the first number. Then we're going to multiply. 3 times 2 is 6. Then add. 2 plus 6 is 8. Now multiply again. 2 times 8 is 16. And then add. 16 and a negative 3 gives you 13. Multiply again. 26. 13 times 2 is 26. And add. We got a number here that tells me that's our remainder. If we get a number here other than 0, that's our remainder. Now, what does this crap mean? It's really easy. See how we started with x to the third? If we have divided an x out, this must be 3x to the second power. We started with a 3. This will be one lower. So 3x squared. This is an 8. It's going to be one lower all the way down. Plus 8x plus 13. And then the remainder. Plus 29 over x minus 2, what we were dividing by. And that's it. There's our answer. Okay, we're going to do a whole bunch more of these. So I don't want you to feel like you have to be able to write the textbook yet. But we're just going to, if it started with a 3, our new answer is x squared. This is the first time we've done synthetic division. So let's go back and practice it some more. Let's go practice it up here on this original problem. So this is what we're dividing by. You know that's a liar. So I'm going to put a negative 7 right here and block him off. And then I'm going to put the dividend numbers. That's an x squared, x, and a number. I'm going to grab their front numbers. That's a 1. That's a 13. And that's a 44. And then I'm going to draw a line. So you're just taking the coefficients of each of the terms of the dividend and using this guy, telling the truth, negative 7. Drop a 1 down. And then you're going to multiply 1 times -7. 13 and -7 gives you 6. Multiply the fact that we got this number, the fact that we got a non-zero number tells me that's the remainder. Okay, let's look at what this says to us. The dividend started with x squared. That means this is an x. So 1x plus 6 plus 2 over what were you dividing by? X plus 7. And there's the answer. That's the same answer we got here. X plus 6 plus 2 over x plus 7. But it takes you no work to do it once you get used to this, and you get used to this fast. We're going to use this a lot in the rest of chapter 3. So we've done it twice. You see how easy it is. You just got to keep the parts apart. Let's do this one. So here's what we were dividing by. Here's what we're dividing into. So this is the guy that goes by himself, and that's going to be a 1. Block him off. Remember, he's always a liar. Anytime you're attached to the x, you're a liar. Now let's grab these numbers. 1, 3, -8, and 4. Bring down the first number. Remember, you're multiplying here. And then you're adding. Multiply and add. Multiply and add. Yay, we get a 0. We love zeros back there. We're going to look for zeros eventually. So we have no remainder here, which we knew we had no remainder here. Let's grab what this equals, what this means. It's the problem started with x to the third, so this one absolutely 100% always starts with one lower exponent. So this is an x squared plus 4x minus 4 with no remainder, and that's what we got after all this. So synthetic division takes you one line. It takes you write it, do the work, and there's the answer. Okay, let's play with a couple more of those. And then we'll find a use for them. Let's see, let me give you x to the 5th plus 12x to the 3rd minus 13 over x minus 1. Okay. Let's see, first we need what we're dividing by. That's always a liar. So I'm going to stick the 1 in a little corner by himself. And then I need to write these coefficients. I've got an x to the 4th, that's a 1 coefficient. I'm missing x to the 4th, so put a 0. I've got an x to the 3rd. I'm missing x squared. I'm missing x to the 1st. And I've got a -13 as the constant. Be sure you get those zeros in there. It'll work out differently if you don't. Well, this answer will work out differently if you don't. Bring the 1 down and multiply. Then add. I'll give you a minute. Yay! You get a 0. Okay, this is our answer. We just have to know what it tells us. We started with x to the 5th. Always, this answer will be one less exponent. So x to the 4th, and then trot down one at a time. X to the 3rd, 13x squared, 13x plus 13. And there's the answer that we're left with when we divide this out. Okay. The next set of instructions will say use synthetic division and the remainder theorem. and the remainder theorem to find. So we're going to use synthetic division, and we're going to use something we haven't talked about yet, the remainder theorem. I'll talk to you about that. To find f of x equals 4x to the third minus 15x squared plus 9x minus 3, and looking for f of 2. Okay, here's the cool thing about the remainder theorem. What it says is that if we do synthetic division using 2 here, the remainder that we get will match exactly if we were to plug in a 2. Let me prove that to you. Let's first plug in a 2 and see what we get. F of 2 equals 4 times 2 to the third, 2 squared, 2 minus 3. That's going to be an 8. That's 32 minus 60 plus 18 minus 3. And I'm just going to cheat in my notes if I can even find it. I don't know. Okay. Negative, let's see. Let's just do it across the ways. 32 minus 60 plus 18 minus 3 is negative 13. Okay. So we plugged in 2. The remainder theorem says is if we do synthetic division on this problem with a 2, we'll get the same answer. Let's see if that works. Let's put 2 in a box. Now don't change the sign because it doesn't say x minus 2. So there's no lying happening here. There's no opposite happening. That is the x, a 2. So if it says x minus something, you do the opposite. But if it's just a standalone number, you use the number. 4, negative 15, 9, and negative 3. The remainder theorem says that this should be a negative 13 right here, that needs to be negative 13 for the remainder. So let's see, let's bring down the 4. 2 times 4 is 8. We get a negative 7 there. We get negative 14 there. 9 and negative 14 is negative 5. Negative 5 times 2 is negative 10, and there we go. F of 2 is negative 13 using just plug in. We just plugged it in and did the math. But when we do synthetic division with it, the remainder will match that. So we don't have to do any of that. We can just do this little bit to find f of 2. Let's try that again. Let me give you f of x equals 4x to the third power minus 5x squared minus 3x plus 4, and you're asked to find f of negative 1. Let's not plug it in. Let's just do synthetic division, knowing that the remainder will be the same as if we plug in f of negative 1. So put negative 1 in a little corner, grab these numbers, and go for it. So I'm getting a remainder of negative 2. That tells me what they asked me to find, f of negative 1, is equal to negative 2. If I plug in a negative 1 there, and there, and there, and then add all those up, I'll get negative 2. So when I plug in a negative 1, when x is negative 1, y is negative 2. Okay, let's play around a little bit more with some synthetic division concepts here. We're going to use synthetic division to divide, and then use the result to find all the zeros. Okay, this is really getting into how we're going to use this. So let's say that they give us f of x equals x to the third minus 7x squared minus 14x plus 120, and they tell us to divide it by x minus 5. So you can see we're going to get 3 zeros here. We'll be able to get 3 zeros. They're telling us one of them is gotten by dividing by x minus 5. So let's use synthetic division to find out the others. Okay, x minus 5, it has the x attached, so you'll be using a 5. Grab the rest of these numbers, 1, -7, -14, and 120. Let's do synthetic division. Now they have told us this will work, so we know we'll be getting a 0 here. They've told us it'll work, so you have to get a 0 there. Bring down the 1. -2 times 5, -24, and -24 times a positive 5 is -120, and you get a 0 out of that. Yay, we did that right. You've got to get a 0 here when they tell you this is a solution. It means that means the same thing. If this is a solution, you will get 0 for a remainder. Let's look at what we've got left over. This started life as x to the third. That means this answer is x squared minus 2x minus 24. So we've already got an x minus 5 happening. We know that's one of our answers. There's the rest of our answers. So x minus 5 will yield one of our answers. Let's factor this. X and x, signs need to be different. What two numbers multiply to give you 24 that are 2 apart from each other? That's 4 times 6. I need, in order to get -2 out of that, I need the 6 to be a negative and the 4 to be a positive. And there we go. So our zeros are 5, -4, and a positive 6. So we were able to factor this x to the third. They gave us 1. They gave us a starting point. We used 5 to break it down to the x squared portion, and then we used our factoring skills to find the others. So they're the answers, the one they gave us, the 5, and the 2 that we determined. Let's do that thing again.
Can you wait so I can finish writing that down?
Sorry, I'm sorry. I should ask first. And there's Adrian back in. Kaylina, you good?
Yes.
Okay. All right, let's see. We've got one more problem, and then I want to show you how to do 2 of the graph problems on my math lab, but I'm going to show them to you by hand. So we're going to run a couple of minutes over. If you need to go, go. I've taken attendance. But then do come back and look at the end of this recording. It'll only be a couple of minutes. It won't be long. Okay, 80x to the third plus 96x squared minus 9x minus 5 equals 0. And they are saying, given that -5/4 is a 0, is one of your answers. -5/4 will plug into here and give you a 0 for a remainder if you do synthetic division. Okay, so we're going to keep the negative on him. It doesn't say x minus. It says that's an answer. So let's put -5/4 in his little box. And then let's pull these numbers off. Okay, grab your calculator. It's why you spent 10 bucks on this calculator right now. Bring the 80 down, and then you're going to multiply these two. So we've got -5 ABC4. That's -5, here we go. Negative right there, 5 ABC4 times 80 equals -100. Okay, add those together. That gives us a -4. Do it again. -5 5 ABC4, negative 5/4, times negative 4 equals 5, because the 4's cancel. Get a negative 4 again, and then we just did that. Negative 4 times that gives you 5, so negative 4 times that gives you 5. And yay, we get a 0. That's what we were wanting. This is what we love to see. So what we've got left now is 80x squared minus 4x minus 4. We've already got x plus 5/4. That's one of our parentheses, because when it's with an x, it does its opposite. And then we've got this mess, 80x squared minus 4x minus 4. Okay, let me keep this piece, drag them along. Okay, I can factor out a 4. Let me do that. Let me factor out, let's factor out a 4. So we get 20x squared minus x minus 1. That's going to make life a lot easier. Because this doesn't have a variable on him, bye, we don't care. So we've got x plus 5/4 times 20x squared minus x minus 1. Okay, keep this guy, keep dragging him along with us, and let's break down this. I know I want to put numbers here that when I put ones here, remember it's going to have to be +1 minus 1, give me a difference of 1. So I'm looking for numbers that are 1 apart from each other. So 5x and 4x, let's see how that works. It gives me a negative 5x and a positive 4x. Good, I'm done. Okay, so each one of these is our 0. This one we know is negative 5/4. We already knew that. This one, 5x plus 1 equals 0. Move the 1 over. We get 5x equals negative 1. Divide by 5, just solving this. We get negative 1/5. This one, move the 1 over, he turns into a positive, and divide by 4. So there are 3 zeros. You'll use your ABC key here. That's going to make your life easier. Okay, real quickly, let me go over the 2 that you're going to look at. Your number 12 on my math lab will have a screenshot that will look like this. There's 0 on the Cartesian coordinate system. And it's going to come in from the left and go up like that, so that you can see this crossed at 1, 2, 3. So you know that, oh, wait, let me start over. They're going to give you this picture, and then they're going to tell you x to the 3rd plus 7x squared minus 21x minus 27 equals 0 is this graph, even though they've only shown you part of it. And they tell you find all the zeros. Okay, you know that one of them is 3. They're showing you on the graph that one of them is 3. So use what we just did on the 2 previous problems. If you know that 3 is one of them, 1, 7, negative 21, negative 27, you know it's going to be a 0 there. They're telling you that's a winner. And then come up with the x squared version here to find the other zeros. So it's the same as the previous 2 problems. You just have to look and see that the x is a 3. That's your job. And you can see it goes 1, 2, 3. It goes through 3. That's a crossing. Then number 13 that you do, they're going to give you 18x to the 3rd. They're going to give you something like that. And then they're going to give you this graph, this t-table, that says at -3, it's negative 980. At -2, it's something. At -1, it's something. At 0, it's -2. At 1, it's -8. At 2, it's 0. Woohoo, there we go. That's the one you're interested in. They're going to give you this whole table, but this is the one that tells you that's a 0. 2 is a 0. 2 is one of your winners. So when you're finding all the zeros here, you're going to use 2 as your synthetic divider. So 18, -47, 23, -2, then, blah, 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 and you'll have an 18x squared plus all the rest there to do 2 sets of parentheses for. So in this one, they show you on a graph what one of the zeros is. You discover the others by factoring. In this one, you see a t-table. 2, 0 on a graph is right there. So you know that's a 0. You're looking for the 0 in the y column. That's what tells you it's an x-intercept. So you know that 2 is one of your answers, and you do the rest of the work based on that. So those last 4 problems are very similar. It's just a different look each time. Here, you have to find it on the graph. Here, you have to find it on the t-table. Okay, that went over a couple of minutes. Let me stop recording.